Hey, what's up, guys? My name is Clay Luttrell, and welcome to Thunder 101. Today, I'm going to walk you through a bunch of different things, but here's a brief overview of what we're going to talk about today. So, we're going to go through the resources available, some safety information, some general information about how lasers work. We're going to talk about settings and LightBurn a little bit. We're going to go over the LCD keypad. And then finally, we're going to talk about maintenance. So first up, let's talk about the various resources you have at your disposal as a Thunder Laser owner. First of all, you've got our training academy. So that's these unboxing and setup videos. Within that academy, you'll find a bunch of other things. How to install LightBurn is in there. How to use a rotary, a bunch of other how-to videos are in there. So I would definitely encourage you to explore those. But for this presentation and deck, I'm going to assume that you already have your machine unboxed, set up, and LightBurn installed. We also have a new user setup guide in the knowledge base. So take a look at that, and all of these links are live in the PDF version of this presentation. LightBurn tutorials. So I'm not going to touch on LightBurn too much just because there is a lot there and because they have a lot of tutorials already. So here's the link to those tutorials you can see, and I'll just let you guys peruse those at your own speed. Training and support. Many of our machines come with a free hour of virtual training. So if you're going to use that, please get your machine set up before scheduling your training. And you can also watch a few sample trainings here. And then as far as support goes, the best path to support is email support. So this is going to, anytime you email support@thunderlaserusa.com, it's going to start a ticket. And all of our technicians can see that ticket and they respond very quickly. So don't think that you're going to have to wait 24 hours to get a response. They are usually very timely at responding. And actually, if you call us for an initial ticket problem, we're really just going to create a ticket for you because email is a much more efficient method of delivering support, not only for us, but for you guys. We're able to give you articles and videos and much more information than what we would be able to give you over the phone. Finally, there's also the Facebook group. Just a word of caution around that. You know, anybody can respond to a Facebook question, so make sure you're careful with what kind of advice you're receiving there. I typically advise people to use the Facebook group for, how-tos or, just settings or, hey, I'm not sure about this or that. Just kind of, hey, my machine's working properly, but I'm looking to do something specific. What have you guys found that is beneficial? So definitely tap into the community for that, and then use our email support for, if there's something actually wrong with your machine or if you really get stuck. Laser safety. The biggest one is fire safety, of course. We are burning materials with a laser machine, so you don't ever want to leave your laser unattended. Actually, the people that do this the most are actually intermediate or advanced users because they get comfortable and they think they can walk away. But you don't want to do that, especially when you're cutting, thick materials or thicker materials. Anytime you're cutting, there's a very real danger of fire. And I would also recommend keeping a fire extinguisher nearby. CO2 or Halotron is recommended just because they're easier on computer components, computer and electric components. You always want to make sure your air pump's operational. You can hit the test button if you've got dual stage air, or just in general, you want to make sure there's always air coming out. And if you ever see a flame coming up around your job, that's not normal. So um, if you see a flame, you're going to want to turn the machine off as fast as you can. Get that addressed. You might be out of focus. You might have too much power. You might be going too slow. I don't know, but you should never see a flame as you're cutting materials. You always want to keep your work area clean. Most fires actually happen because the debris next to the material that you're cutting catches fire, not the actual material that you're cutting, but actually the little pieces that were left over from the job before. That's usually what catches fire. That being said, we do have a smoke alarm, a heat alarm inside the machine. Inside the Nova machine, it's located here on the x-axis. Bolt heat alarm, it's here on the x-axis. So just keep an eye on those and just know that that's one of the good things that we do. A lot of machines don't have this safety feature. So if a fire does start in your machine, you're going to get a loud prompt right away. Electrical safety, the most important thing is just to make sure it's wired right. You want to make sure you've got a good open circuit. Most of our machines, except for the smaller machines, require a dedicated 20 amp circuit, but there's also an article right here about what the electrical requirements are, and of course make sure there's no water, especially around the if you're using an air compressor or anything like that, water tends to build up around those. Fumes and eyes. So, anything that you burn, you're breathing it in. So if you're burning wood, it's just like breathing in campfire smoke. And, always, if you have any questions or if you're concerned, check the material safety data sheet. You're always going to want to wear safety glasses. And of course, don't ever burn PVC in a machine. It's toxic, not only to the machine, but also to you and yourself. It's quite dangerous. So just stay away from PVC. Now we can talk about just generally how a laser works. So a laser machine might seem complicated at first, but really I like to think of it as just a light bulb and a couple of mirrors and a lens, right? So you've got a switch that turns on the laser power. It goes on and off, and it's telling this laser when to fire. And that's all it's doing as it moves across the bed and you're doing engravings. It's just saying on, off, on, off, on, off, on, off, on, off. And obviously at different powers and whatnot. And so as that laser turns on and off, it hits a mirror, and mirrors reflect light, right? So it comes down here, comes down the y-axis, across the x, and then down into your focal lens here before it hits your material. And then you've got a few motors. You've got a motor controlling your y-axis. You've got a motor controlling your x-axis. And those motors are just saying, hey, one step this way, one step back, one step left, one step right, so on and so forth. And then you have a control for your z-axis. That's your laser bed, like the honeycomb bed moving up and down. That's your z-axis. The beam path, most important thing to keep in mind, like, anything that gets in the way of this beam path, it's going to weaken the laser beam. So specifically smoke. As you start to engrave things, if your ventilation's not right or your air assist isn't right, you're going to get smoke up here through the beam path. And if there's smoke in the beam path, then it's going to dilute your laser beam. And as you move, so at the top left of the laser bed, it's super easy for your laser beam to stay strong. But as you move down to the bottom right, you'll notice that it's a lot easier for this smoke and other things to interfere. So you'll notice that. And then, finally, don't adjust these mirrors. Don't try to do an alignment without talking to us first. Usually it's something else. Lesser quality machines, when you get them, you have to actually do a mirror alignment. You don't have to do that with our machines. Our machines come aligned, and they generally don't come out of alignment. So, if the machine is not well made, as this head is banging back and forth, left and right, engraving all the time, these mirrors can get out of alignment, and you have to do an alignment every so often, every week or two, or, whatever. But with our machines, they really don't get out of alignment. So you're not going to have to worry about that unless you have a head crash where you bang into something. It's just not really a problem that we see. You shouldn't have to mess with these mirrors too much. So don't mess with them unless instructed to. Finally, there's some machine sensors on the machine. So like if your door is open, your lid is open, or the housing for the laser tube is open, that's going to give you an error on the LCD machine, on the LCD saying machine protected, work pause, or something like that. So just be aware of those different sensors around the doors. If your machine's not working, that's probably the problem. Cooling system. I remember when I first got into lasers, this chiller really freaked me out. I don't know why, but there's really not much to it. You put 2 gallons of distilled water in this thing, and you'll notice the 2 tubes coming out the back of it. It's just pumping cold. So this thing's chilling water, and then it pumps cold water out and around the laser tube. And as that laser tube heats up, it's getting hot, and this cold water that's being circulated around it is keeping it cold. And that helps with a lot of things. It also helps with the laser tube life. It's super important, but really there's nothing to know. Like, you just put the water in there and the machine will tell you if it's not on. So if you ever forget to turn it on or something like that, it's not going to let you run anything. So, and again, this is only for our glass tubes, not our RF tubes on Bolt or Odin. Okay, so this is the exhaust system. This is the exhaust system on the Bolt. This is actually what's sucking the smoke out of the machine and then pushing it to the outside. Main thing here is you just want this hose to be as short as possible. You don't want to be, running this thing a long ways. If you do have to run it a long ways, just give us a call so we can give you some instructions about that. But generally, you just want this to not have too many bends and to be as short as possible. And then also, this turns on when you start the job. So when you plug the machine in, this isn't going to be running until you start a job. We actually have a lot of people call in saying their exhaust isn't turning on, but that's just because they hadn't run a job yet. Air assist. So air is pumping through this hose right here. And it's blowing down here close to the lens. It's keeping that smoke away from the lens. So if this is off, the smoke can come up in here into the tube assembly, and that smoke will it'll crack a lens whenever the smoke and the laser beam hit the lens at the same time. It leaves marks, but that's eventually how your lens will wear out. But if the air is off, then it's going to crack that lens, almost immediately in some cases. So be real careful if you're adjusting your air, for low pressure for engraving. Make sure you turn that back up for cutting applications. Over here we got the dual air. It's on our Nova systems and some of our other systems. So the high volume is for cutting and the low volume is for engraving. So this would be fill, the fill function in LightBurn, and this is the cut function in LightBurn. And then you can test each one of those to kind of, you can stick your finger under there and see what kind of air is coming out, where you've got it set. And, yeah, righty tighty, lefty loosey. Burning. So just kind of a general overview of burning. If we think about a lighter, and if you held a lighter up to your hand, and if you move the lighter back and forth across your hand, then it doesn't burn you too bad. But as you slow down moving back and forth, it's going to burn your hand more and more. It's the same thing with a laser beam, right? So as you slow down your speed, you're going to burn more and more and deeper and deeper. Likewise with power, if you have that lighter, you turn up the power, it's going to burn your hand faster. So you turn down the power, it's going to burn your hand slower. It's the same thing. The interval or lines per inch, that's this guy. So as your machine is engraving, this is specific to engraving. Your machine is just doing a bunch of passes, left, right, left, right, left, right. And the interval is telling the machine how far down to come each time. So like typical line interval is 0.08 millimeters. So the machine burns across, comes down 0.08 millimeters, and then it burns across again, down 0.08, burns across again, down 0.08, burns across again. And then another measurement for this is lines per inch. So again, it's just measuring how many lines per inch it's putting in there. So those are really the same measurement, just different ways of taking it. And then back here I just want to cover, kind of different, focus. So you can also pull the machine away from the laser beam. And of course, the laser beam gets weaker or stronger, depending on, if you're moving closer or further away. Your different heads here, sorry, different lenses, 4-inch, 2.5, 2-inch, 1.5. So you'll see the spot size get smaller with the 1.5-inch lens. So that means you got a real small dot. And so you can do higher detail engravings with that 1.5 or 2-inch lens. With the 4-inch lens, your spot size goes up to 0.3 millimeters. So it's a bigger spot, but it's a much longer length. So that's why this lens is better for cutting thick materials, because it's nice and long and straight for a long period of time. But again, what you sacrifice there is that the spot size. And then actually with the 4-inch lens, you can engrave faster because it's a bigger spot size, and so you can increase this line interval, and you can actually engrave faster. So once you get better, if your engravings aren't very detailed, you can engrave with the 4-inch lens and, increase this line interval, and then you don't have to make so many passes, and it can drastically speed up your engraving time. Settings and LightBurn overview. So first, I just want to talk about the difference in materials. If you go to Home Depot, buy a piece of birch plywood, and then you go buy a piece of birch plywood the next day, those two pieces of plywood are not going to be the same. So there's lots of differences, even within the same batches of acrylic, 1/4-inch cast acrylic, the next piece might be slightly different. So there's no perfect settings. These are all just kind of roundabout figures, and you kind of just got to get close, right? Because everything can change. Your lenses might be a little more dirty one day or cleaner. Your tube, as it gets weaker over time, 2 years down the road, it's not going to be putting out as much power as it was, when you first got it. So just remember there's no perfect settings. And then cutting versus ablating versus scoring. So cutting, you're cutting all the way through the material. Ablating, you're like taking think about the powder coating on a Stanley cup. you're taking that powder coating off. Scoring is kind of like cutting, but not all the way through. So a lot of the times people use this, like if they had this piece of wood, they would score, 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 these lines through this. And then they could actually bend this piece of wood because it's got these cuts through it. So it allows them to do some cool things. You can also do like these letters down here that say cut speed. That might have been scored, like just a real quick. It was a cut, the laser just made this C just like that, and then made a U as opposed to an engraving, which would have gone across like this. And then of course engraving, you're just kind of cutting out a notch, and you can either just gently braze the top of it, or you can, basically cut all the way through it. And then finally, so we have our own material test file. There's a video on it right here. But then also now in newer versions of LightBurn, they actually have this function built in. So here's a link on how to do this. But anytime you have a material, if you've got some to spare, this is always a good way to test a whole bunch of different settings before using it, so you can see all the different combinations, right? Like this is cutting, so this is cut speed, so it's slow, 5 millimeters a second, 10 millimeters a second, up to 25. So this is fast cutting, and then low power here, so this is fast cutting and then low power, all the way up to, slow and high power. So of course, this one is the strongest up here. Materials libraries. So as you find good settings on materials, you can always save them. So that's down here. There's a separate tab. Normally this is on the laser tab, but on the library tab, you can load materials and save different parameters that you want. We actually have presets for all our different laser tubes. So if you've got a Nova 35 80 watt, we've got an 80 watt library you can just load up in here, and all those materials will be ready to go. And then here's the material test function in LightBurn again, and then another, the same video as before, material test file. Main settings. So first of all, there's color mapping, right? So these are gonna process in the order that they are here. So it's gonna do the black one first, then the blue, then the green, then the red, so on and so forth. And then you can see the black is set to fill, so it's going to engrave this one, and then it's going to cut this one, and then my colors are kind of messed up here, but you get the point. It's going to cut these, fill these, and finally, this image I brought in, you can see that's the very last one that came in as an image. And then also you can tell your machine, hey, either output this layer or don't output this layer. You can hide it. Like if you click this show button, then this is going to disappear. And then you can also turn off your air assist on and off. Of course, you want to be careful with that, like I said. But you can turn the air on and off there. Fill equals engrave, line equals cut. Detailed settings. So if I double clicked on that black layer, this is what comes up. Again, you can tell it not to output. You can change the speed. You can change, so max power, min power, generally, you just keep these the same. This should be 70 and 70. Only time you might mess with this is if you're cutting and you're going around a corner, like a curve. The machine doesn't know, it's actually going slower around that curve than what it thinks. So you might have to tell it to lower the minimum power. Usually this is only the case in if you're doing something real thin like fabric or cardstock. So if you notice that you're getting kind of overburn as you're cutting around corners, That's when you want to take this minimum power down a little bit, but generally it doesn't play a whole lot. And then again, your line interval, like I said before, you can either do, you know, line interval or lines per inch. As you change this, like if I took this to 0.09, then this lines per inch changes as well. Bidirectional fill, that just means the laser is burning as it's going each different direction. So it's burning left, right, left, right. Whereas if you turn that off, it would just go burning to the right, burning to the right, burning. It has to make twice as many passes. It is more accurate, but as long as you have your scan offsets in, which this is in our startup guide, then you're more than welcome to use that bidirectional fill, and it will engrave much faster than when that's off. Lasering out of focus, focus. So sometimes you do want to laser out of focus. Some materials call for that, like glass. So when you're engraving glass, you're just trying to barely touch the surface, and you just want to barely micro shatter it. So sometimes kind of softening that blow will help you get better results. So keep that in mind. That's something to play with, kind of another setting, if you will. And then when you're cutting thicker materials, you want to focus to the middle of the material. So usually you're focusing to the top of the material, but if you're cutting anything 3/8 or more, you want to focus to the middle of the material so that you get the most out of that hourglass shape of the laser beam. Job start position. So the job origin, you when you hit origin, so there's a button on the LCD, I'll go over in a minute, it's called origin. And that's kind of like where you're telling your machine is home. And then and that's where the jobs are going to start from. So if you bring that laser head out into the middle of the machine and hit origin, and then you're using user origin, and this is what I call center engraving. So this is great if you have like a coaster, a circular coaster. Then you can just put the laser beam right in the middle of that coaster, and it's going to engrave your image around that. You can also, a lot of people use this top left one, and then if you have your origin on the top left of the material, then it's going to engrave down bottom right. But if you hit the frame button, that's going to show you exactly where that job is going to go. This is just kind of job placement type stuff. But definitely check out the center engraving and then also use it on the top left. As far as where to start from, I wouldn't recommend using current position. Just user origin or absolute coordinates. Mostly user origin. If you're using the camera, absolute coordinates. Absolute coordinates just means it's going to engrave exactly where it is on your LightBurn drawing, so if it's, if you got a 400 by 600 drawing and it's at, 100, if it's in this section, then it's going to engrave right there. But again, mostly using that on the camera, generally user origin is what's best. Running a job. So once you're ready to send the job, you're going to want to hit send. Don't hit start, but you can actually take the start button off. There's a lot of reasons you don't want to do that, but one of the big ones is that sometimes the file won't get transferred all the way over. It's just, if you got a big file, you might have some data interference or something like that. So hit send the file to the machine, walk over to your machine and hit play. Before you do that, check your focus. Make sure you're at, 6 millimeters if that's what your head calls for. Make sure you're planar. Check the top left, the bottom right. Make sure the piece of whatever you're engraving is flat in all areas. And if it's not, then you might need to pin it down or something like that. Checking the squareness. You can jog the laser head. So if you have a rectangular piece of plywood that you put in there, you lay it in the machine like this, and then you can just jog that laser head over to the right and just make sure it's in line with your material. And you can jog the laser head down and make sure it's in line with the material. So that way you know you're square. And then finally you hit the frame button. And again, that frame button is going to outline your job. So it's going to show you exactly where it's going to engrave. LCD and the keypad. So this is the Nova keypad. These arrows right here, the Z up, Z down. So that's your working table. That's your honeycomb table, moving up and down. Your left, right, up, down arrows, that'll be your laser head jogging left and right. Here's a preview of whatever you're going to engrave. The pulse button will just pulse the laser. It'll fire the laser real quickly. This is good if you're doing alignment, or if you just want to make sure your laser is operational, just do a quick fire. Speed. This will change the jog speed and the frame speed. So if you're needing to, sometimes when you hit these left right buttons, if you're just trying to barely touch it over, it's going to jump too far because this is set for like 200 millimeters per second. You hit this button and turn it down, 50 or 20 millimeters per second. And that way you can really do kind of micro moves to get the laser head exactly where you want. Just make sure you change it back before you hit the frame button. Otherwise, it's going to get a real slow frame. And you're going to be sad. But everybody does it. So remember me whenever that happens. File. This will pull up all the files inside your... So this has a gigabyte of memory. And you can send over, a bunch of files if you want, and you can just play them directly from the LCD without having to, go over to your computer. The origin button, again, sets the job origin. So that's kind of like your home button. It's telling it, hey, this is where I want to start everything from. And then the frame button outlines. The escape button gets you out of which I'll go through the menu too here in just a sec. The escape button will get you out of there, and it'll also take you back to the origin position. So if you start wandering around with your laser head and you're like, hey, I want to go back to origin, just hit escape. Start, pause. I think those are self-explanatory. Inside the menu button, I just want to touch on the autofocus. So you just hit that, and as long as your material is within the autofocus sensors, then that's how you activate the autofocus. You move, that's going to move your rotary, and then diagnosis can be helpful if you have any any sensors that are going off, water protect or machine protect. Those are going to light up here. Can be useful sometimes if you're trying to troubleshoot. Speaking of troubleshooting, some common error messages. So water error. So this just means your chiller's off. You'll get this little water error work pause thing. Machine protected means one of your lids is open, not enough extended space. So if you try to engrave right up next to the edges of the machine, if this is the work area, if you line up your engraving right here, it's not going to work because the machine has to actually go past your engraving to engrave, right? So you're going a little bit over the engraving. So you got to leave yourself a little bit of cushion. And the faster you go, the more room you need. But just know if you get that message, it means you're too close to the edge of the machine. And then frame slop just means you're basically outside of the parameters of the machine. You've done something wrong. You probably got an outlier somewhere on your file or something like that that's making your machine think that your project is bigger than your work area. Keypad for the bolt or Odin. So pretty self-explanatory. Again, Z up, Z down, X, Y, left, right, up, down, rotary, turn, stop, play. I do want to mention the U disk button up here. So if you have files on a USB, if you got a computer far away and you want to load files onto a USB to transfer over, you can do that. You don't have to have a computer mounted to the machine. Here on the home screen, so you got a preview of the image, the file name, max power, min power, the job runtime, your speed. This is saying, it's 35% done. It's minute 55 through. The manual tab will give you manual functions, just like the actual physical buttons on the outside. File, very similar to the other one. You've got your list of files. Menu will give you a list of menu settings. This will instigate the autofocus. This will set the origin, and this will frame. So pretty similar to the Nova screen. Maintenance. Mostly cleaning the lenses and mirrors. So the most important is this lens down here that's closest to the material. That's what's going to get dirtiest the fastest. So just keep checking that. At the bare minimum, once a day if you're running a lot. I'd say every couple of hours, depending on how much smoke you're putting out. Just keep that lens really clean. And then every so often, just check this next mirror, which this is a little metal key that'll be in your toolbox that pops that mirror out. That little O-ring right there, it's a little key, and you can just unscrew that and easily pop that mirror out and clean it. And then, so I mean, these optics get, this gets dirtiest the fastest. This is the next fastest. Then your mirror 2 is the next fastest, so just think of it that way. Like this is always the dirtiest, and just work your way back. But just always keep those optics clean. Just keep checking them. Again, don't mess with the mirrors. Don't try to adjust them. You adjust them with the Allen bolts here and the little thumb screws, the little gold thumb screws. But generally, don't mess with those unless you talk to tech support first. It's a big rookie mistake to start messing with the alignment. Then your machine's all out of whack and everybody loses. So other than that, generally keep the machine clean, free of debris. Wipe it down, clean it. It's just like any other tool. Just keep it clean, and then lubricate the X and Y rails periodically, just as needed. Not very often at all. Just if you start to see gunk start to build up, clean them off, lube them down, stuff like that. And that's it. I hope you guys enjoyed this. I hope it was helpful. And we're always here for you. Just email us at support@thunderlaserusa.com, and we'd be happy to help you out. Happy burning.